Somewhere beyond the edge of our solar system, in a region so cold and so silent that scientists call it the space between stars, something moved. It was not a flicker of light. It was not a random burst of cosmic noise. It was a pattern, a signal that should not exist, detected by a machine that has been flying alone for nearly 50 years. Voyager 1, humanity's most distant traveler, was the only spacecraft close enough to notice it. And what it recorded has left some of the world's top scientists staring at their screens, unable to explain what they are looking at. Tonight, we are going to walk through exactly what Voyager saw, why it matters, and why NASA still has no official answer. To understand why this moment is so strange, you first need to understand what Voyager 1 actually is. Launched by NASA on September 5th, 1977, Voyager 1 was originally designed for a relatively simple mission. Fly past Jupiter and Saturn, take photographs, gather data, and send it all back to Earth. Nobody expected it to still be working today. Nobody expected it to become the farthest human-made object in existence. Yet here we are, decades later, and Voyager 1 is still transmitting, still traveling, and still teaching us things we never anticipated. Right now, Voyager 1 is more than 15 billion miles from Earth. It has already left the heliosphere, the protective bubble of charged particles created by our sun, and entered interstellar space, the region between star systems. A radio signal from Voyager, traveling at the speed of light, takes over 22 hours to reach Earth. Think about that for a moment. When Voyager sends a message, we are not hearing what is happening now. We are hearing an echo from almost a full day in the past. Onboard Voyager 1 is something many people forget about, the golden record. It's a phonograph disc containing sounds, images, music, and greetings from Earth in dozens of languages, created in case any intelligent life ever intercepts the spacecraft. It was humanity's message in a bottle sent into the largest ocean imaginable. For decades, that record has simply been floating through the dark, a silent ambassador for our entire species. Voyager's mission has already given us historic discoveries. Active volcanoes on Jupiter's moon, Io, the intricate structure of Saturn's rings, and the very boundary of our solar system. Every photograph it sent back rewrote a textbook somewhere on Earth. Every measurement it took added another piece to the puzzle of how our solar system actually works. What makes Voyager 1 even more remarkable is the sheer age of its technology. It runs on computer systems with less processing power than a modern calculator, powered by a radioactive decay generator that has been slowly losing strength for nearly 5 decades. Engineers back on Earth have had to become historians of their own equipment, digging through old manuals and retired programming languages just to keep communication alive. Every single command sent to Voyager has to account for a signal delay of nearly a full day in each direction, meaning there is no room for improvisation. Every instruction must be planned with extreme precision, because a single mistake could end the mission permanently. Despite all of that, Voyager 1 has outlived almost every prediction ever made about it. It has survived radiation storms, equipment failures, and the harsh unpredictability of deep space for far longer than its original engineers believed possible. That resilience is part of why this new event feels so significant. This is not some experimental probe on its very first flight. This is a seasoned, battle-tested machine that has seen more of deep space than any other object built by human hands. And when a machine like that starts recording something it cannot explain, people listen. But nothing in its long history prepared scientists for what happened next. It started small. A tiny fluctuation in the data stream, barely a blip, the kind of thing engineers see all the time and usually dismiss within minutes. At first, the team at NASA's Jet Propulsion Laboratory assumed it was nothing more than background interference, the normal noise that comes from operating a spacecraft billions of miles away using technology older than most of the engineers monitoring it. But the anomaly did not go away. It repeated. Then it changed shape as if it were adjusting itself. Engineers noticed a faint but consistent shift in the frequency pattern, something that did not match any known form of cosmic radiation, solar interference, or equipment malfunction. Then came the detail that made people stop scrolling through their morning coffee and start paying attention. The signal appeared to be accelerating, a ripple in the data that seemed to be moving faster than it should, faster than anything Voyager had ever recorded before. For a machine that has spent decades cataloging the predictable rhythms of deep space, this was something new. And the question on everyone's mind became painfully simple. What could possibly behave like this out there, in a place where nothing is supposed to be? Naturally, the scientific team did what scientists always do first. They tried to explain it away with the most logical answers available. Could it be an asteroid passing near Voyager's sensors? Unlikely. Asteroids don't produce structured radio patterns, and nothing of that size was tracked in the region. Could it be a comet, its icy tail interfering with instruments? Also ruled out. Comets leave a very specific signature, and this did not match. Was it a simple sensor error? A glitch in hardware that has been operating far beyond its expected lifespan? Engineers ran full diagnostics. Every system checked out normal. Could it be a software bug, some kind of corrupted code finally surfacing after 50 years of operation? They rebooted subsystems, cross-checked backups, and compared the anomaly against every known fault in Voyager's programming history. Nothing matched. What about gravitational interference, perhaps from an undiscovered object bending the spacecraft's trajectory or affecting its instruments? The math didn't support it. Voyager's path remained stable, unaffected by any measurable gravitational pull. One by one, every rational explanation collapsed, and with each rejected theory, the room grew a little quieter and the questions grew a little heavier. If it wasn't an asteroid, a comet, a glitch, a bug, or gravity, then what exactly was Voyager detecting out there in the dark? The team even considered more exotic possibilities. Could it be a form of cosmic background radiation shifting due to some unknown interaction with the interstellar medium? Researchers ran the numbers, comparing the anomaly against decades of archived data from other deep space missions. Nothing in the historical record matched the pattern. Could it be interference from Earth itself? Perhaps a stray signal bouncing off something in our own atmosphere and being misread by Voyager's aging instruments? That too was tested and quickly dismissed, since the signal's characteristics were consistent with an origin far beyond our solar system, not anywhere close to home. By this point, the investigation had stretched across multiple departments, pulling in astrophysicists, signal engineers, and even independent researchers who don't normally work directly with NASA. Every possible mundane explanation had been tested, documented, and crossed off a growing list, and each rejected theory was logged carefully, building a paper trail that would later prove critical for verifying the discovery. And that is exactly the moment when a routine anomaly investigation quietly transformed into something much bigger, something that would soon capture the attention of the entire world. Then came the moment that changed everything. When the team finally isolated the signal and mapped its structure across a wider portion of the sky, they discovered it wasn't coming from a single point. It was coming from multiple points, 289, then 300. Then, after further refinement, the number settled at 305 distinct sources, scattered across a region of space Voyager was passing through. 305 individual points, each emitting a similar fluctuation, each slightly offset from the others in timing. At first, researchers assumed this might simply be noise duplicated across sensors, but when they plotted the exact positions and timing intervals, something extraordinary emerged. The points weren't random. They formed a pattern, a loose, shifting formation that seemed to maintain consistent spacing relative to one another, almost like ships holding position in a fleet. And it got stranger. The timing between each signal wasn't chaotic. It followed a rhythm, a repeating interval, almost like a heartbeat, pulsing across all 305 points in a way that suggested coordination rather than coincidence. Natural phenomena, cosmic radiation, background noise from distant stars, none of it behaves this way. Coordination implies structure. Structure implies intention. And intention is the word that no scientist wants to say out loud, because once you say it, you can't unsay it. This was the first true wow moment of the entire event. The instant when a strange signal stopped looking like a glitch and started looking like something else entirely. From here, everything the team uncovered seemed to raise the stakes even further. The first shock came from the propulsion readings. Whatever these 305 points were, their positions shifted at a rate that, according to standard physics, would require an amount of energy far beyond anything humanity has ever engineered. Objects simply do not accelerate like this without leaving behind massive amounts of detectable exhaust, heat, or radiation, yet none of that was present. Next came the speed calculations. When engineers cross-referenced Voyager's own trajectory data with the shifting positions of the anomaly, the resulting numbers didn't make sense. The objects appeared to be closing distance and repositioning at speeds that should be physically impossible for anything without an enormous, continuous energy source. And still, there was no visible propulsion signature at all. Then came the communication patterns. The pulsing rhythm noticed earlier began to show structured variation, not just a repeating beat, but subtle differences in pulse length, almost like a form of Morse code stretched across radio frequencies. Nothing conclusive, nothing decoded, but enough structure to make several researchers privately admit that it resembled a communication protocol far more than random cosmic static. Every new dataset made the last one look small. This wasn't a single strange reading anymore. It was a growing mystery with real momentum, and it was about to spill out of the research labs and into the public eye. There was also the matter of consistency. In most natural cosmic events, patterns degrade over time. Signals weaken, structures dissolve, and randomness eventually reasserts itself. But this pattern didn't degrade. If anything, it appeared to sharpen with each new observation, as though whatever was producing it had a level of stability that natural phenomena simply do not maintain. Researchers began cross-checking the data using multiple independent receiving stations around the world, hoping that a wider network of instruments might reveal an error somewhere in the chain. Instead, every additional station that picked up the signal only confirmed what the first team had already found. The pattern was real, it was repeatable, and it was not going away. Word doesn't stay contained for long, especially in the age of the internet. Amateur radio operators, some of whom tracked deep space communications as a hobby, began picking up unusual chatter on frequencies close to those NASA was monitoring. Forums and online communities lit up with speculation, screenshots, and theories long before any official statement was released. Inside NASA, the reaction was reportedly a mixture of caution and quiet excitement. Internal briefings were held. Data was reportedly encrypted and restricted to a smaller circle of senior researchers, a move that only fueled public curiosity even further. When information is locked down, people notice, and when people notice, they talk. Around the world, other space agencies and independent observatories began redirecting their own instruments toward the same region of sky Voyager had been monitoring, hoping to catch a secondary signal or confirm the anomaly independently. For the first time in years, a Voyager-related story wasn't just a niche topic for space enthusiasts. It had become a global point of fascination, discussed on news programs, debated online, and picked apart by scientists and skeptics alike. The mystery had officially left the void of deep space and landed right here on Earth. Social media accelerated everything. Clips of hastily recorded briefings, screenshots of leaked internal memos, and amateur analysis videos spread within hours, each one adding a new layer of speculation to a story that official channels had barely begun to address. Universities reported a spike in public interest around astrophysics courses. Podcasts dedicated entire episodes to breaking down the timeline of events. Even people who had never paid attention to space news before found themselves refreshing their feeds, waiting for the next update. Meanwhile, NASA's public communications team faced a difficult balancing act. Say too little, and the silence itself becomes the story, fueling wild theories with no evidence to counter them. Say too much before the data is verified, and they risk spreading unconfirmed information to a global audience hungry for certainty. The agency ultimately chose a cautious, measured approach, promising updates as more data became available, but for many watching closely, that caution only made the mystery feel even more significant. Just when it seemed like the story couldn't get any stranger, Voyager itself began behaving abnormally. Engineers monitoring the spacecraft's telemetry noticed something they hadn't seen before. Dormant systems, subsystems that had been powered down or unused for decades, appeared to activate briefly on their own. Memory sectors that should have remained untouched showed signs of access. It wasn't a full malfunction, but it wasn't normal operation either. Then came unexpected changes in how Voyager was routing its own data, almost as if the spacecraft had quietly rerouted certain processes without any command being sent from Earth. For a 50-year-old machine running on decades-old software, this kind of unplanned activity is deeply unsettling. Engineers who have worked with Voyager for years, people who know its quirks better than almost anyone alive, reportedly describe the behavior as something they simply couldn't account for using any known explanation. Was Voyager reacting to something nearby? Was it responding to whatever those 305 points actually were? Nobody could say for certain. But one thing was clear, the mystery was no longer just about what Voyager had detected outside itself. It was now about what was happening inside the spacecraft too. Some engineers pointed out that Voyager's aging hardware is known to occasionally behave unpredictably as components degrade, and that alone could explain isolated glitches. But what troubled the team most was the timing. The unusual activity inside Voyager didn't happen randomly. It happened in close alignment with the strongest readings of the external signal, almost as if the two events were connected. Coincidence was still on the table, but with each passing day, fewer people on the team seemed willing to bet on it. To really appreciate how remarkable this moment is, it helps to step back into Voyager's past. In 1977, two nearly identical spacecraft, Voyager 1 and Voyager 2, launched within weeks of each other, beginning what would become one of the most successful missions in the history of space exploration. Voyager 1 reached Jupiter in 1979, capturing detailed images of the planet's swirling storms and discovering active volcanic eruptions on its moon, Io, something no one had ever observed on another world before. By 1980, Voyager 1 arrived at Saturn, revealing the astonishing complexity of its rings and studying its largest moon, Titan, in unprecedented detail. After completing its primary mission, instead of shutting down, Voyager 1 kept going, propelled by nothing more than the momentum from its original launch and a series of carefully planned gravitational assists. Over the following decades, it crossed into the outer reaches of the solar system, eventually reaching the heliopause, the boundary where the sun's influence gives way to interstellar space in 2012. It became the first human-made object to cross into that unknown territory, carrying with it the golden record, our species' message to whatever might one day find it. Along the way, Voyager 1 gave humanity some of its most iconic images, including the famous pale blue dot photograph taken in 1990 at the request of astronomer Carl Sagan, showing Earth as a tiny speck of light suspended in a sunbeam, nearly 4 billion miles away. That image became a symbol of how small and fragile our world truly is within the vastness of space, a reminder that everything humanity has ever known exists on that single, pale, blue point of light. Every discovery Voyager made shaped how we understand our place in the universe. Its journey has spanned multiple generations of scientists, some of whom worked on the original mission in the 1970s, and have now handed responsibility over to engineers who weren't even born when Voyager first launched. That continuity, decades of dedicated work passed from one generation to the next, is part of what makes this spacecraft feel less like a machine and more like a living piece of human history. And now, decades later, it may be adding one more extraordinary chapter to that legacy. As researchers continued analyzing the data, the scope of the mystery only grew larger. What had first appeared to be 305 separate points began showing signs of forming a much broader, more expansive structure across a wider stretch of space than anyone initially estimated. Scientists who have spent their entire careers studying deep space data described their reactions in strikingly emotional terms. Several reportedly admitted, off the record, that this was unlike anything they had encountered in decades of research. Some expressed genuine unease. Others described a kind of reluctant excitement, the sense that they might be witnessing something that could reshape our understanding of what exists beyond our solar system. And yet, for every answer the investigation produced, at least 2 new questions took its place. What is generating the coordinated movement? Why did Voyager's own systems react the way they did? Is there any connection between the signal's rhythm and the golden record Voyager still carries? Nobody has offered a definitive answer, and that uncertainty has only deepened the emotional weight of the story. This is no longer simply about data points on a screen. It's about the very real possibility that humanity's oldest active explorer just encountered something we are not yet equipped to understand. For a mission built on curiosity, that uncertainty carries a strange kind of poetry. Voyager was never meant to find answers to questions we hadn't even thought to ask. It was built to explore, to observe, and to report back whatever it found, without judgment and without expectation. In many ways, this moment feels like the purest expression of that original purpose, a machine doing exactly what it was designed to do, even if what it finds leaves us with more mystery than clarity. We sent a message into the dark nearly 50 years ago, not knowing if anyone or anything would ever receive it. Now, for the first time, something out there may have responded. Voyager 1 is still out there, still listening, still transmitting, still the loneliest and most far-reaching piece of human engineering ever built. Whatever those 305 points truly are, whatever caused Voyager's own systems to stir, the story is far from finished. NASA continues to monitor the region. Scientists continue to search for answers. Independent researchers around the world continue to compare notes, hoping that a fresh set of eyes might spot something the original team missed. And somewhere, 15 billion miles away, humanity's oldest emissary keeps moving forward into the unknown, carrying our voice, our music, and now, perhaps, a question we never expected to ask. Maybe it was nothing more than an extraordinary natural phenomenon, one that simply hasn't been documented before now, waiting patiently for the right instrument to finally notice it. Or maybe, just maybe, Voyager 1 brushed up against something far beyond our current understanding, something that noticed a small metal traveler carrying greetings from a tiny blue planet and quietly responded in the only way it possibly could. We may not have that answer today. We may not have it next week or even next year, but one thing remains absolutely certain. As long as Voyager 1 keeps transmitting from the darkness, humanity will keep listening, watching, and wondering. This story isn't over. It's only just beginning. Stay close, keep watching the sky, and when the next update comes in, you'll be the very first to know.